we are going to have a quick run through series on Igcse geography. So we're going to be looking at physical geography aspect. Now, your syllabus content 2.1 has to do with earthquake and volcanoes. So in this video, we're going to complete the content of earthquake and volcano. So if first, the learning objectives for us to be able to describe the main types and features of volcanoes and earthquake. We should also be able to describe and explain the distribution of earthquake and volcanoes. Usually you'll be given a map and you use that to describe it. We should also describe the causes of earthquake and volcanic eruption. So what triggers earthquake and volcanic eruption. So lastly, we are going to look at the impact, opportunities, and management of earthquake and volcanoes. So quickly, let's look at the first thing is types of volcanoes and their major structure. So let's look at the structure of a volcano. Now, usually this is how a volcano, the structure of a volcano look like, and the major keywords that represent each of these features. Now, let's start from the bottom up. Here at the bottom we have the magma chamber, which is a store of underground magma, which are molten rocks. So what are magma? Magmas are molten rocks that are still beneath the ground, usually within the mantle in the earth crust. Then we have the vent, and also we have the main vent and we have the secondary vent. So the secondary vent are places where magma reaches the surface without going through the main vent. So like the side of the volcano, without passing through the main vent to get to the surface. Then the main vent itself, which is the main tube that connects the magma chamber to the surface of the earth. Then what is a lava? They are molten rocks that reaches the earth's surface. So once molten rocks that is beneath get to the earth's surface, it becomes a magma. Then a crater is like a dome shape or circular shaped depression at the top of a volcano. So usually you see it like a dome or circular shape at the top of a volcano. Is usually referred to as the crater. Then once the volcano erupts, there are usually ash, steams, and gas. These are cloud which is pushed out of the volcano. And we also have things called the volcanic bombs, which are this. So volcanic bombs are rocks and larger debris that are thrown into the air during an eruption. So quickly, what are the types of volcanoes? There are usually two types of volcano your syllabus expects you to know, which is the shield, and you also have the composite cone volcano, or it's usually referred to as the stratovolcano. Now, if you look at the composite cone volcano, which is this, usually in the exam you'll be asked to differentiate between a composite cone volcano and a stratovolcano, and also you'll be asked to identify the type, usually from a diagram. Now, the first thing you should look at is that a composite cone volcano have a steep slope, while it has a steep slope, and also a composite cone volcano have a higher height, so it's usually taller than the shield volcano that we are going to look at shortly. Now, the vent lava have a high gas pressure and usually is very explosive. Now, a composite cone volcano is formed along destructive plate boundary. We are going to look at plate boundary during the course of this class. Destructive plate boundary, that is where you find composite cone volcano. So as a result, it usually releases pyroclastic materials also, and composite cone volcanoes are the ones that have secondary vent, but you find out that the width of the volcano is usually small, so it's not that wide, but it has a higher height. Then if you look at a shield volcano, this is a shield volcano, so you find out that it is wide at the base, a very wide base and a low height. Now, remember, this is formed from andesitic lava, which is usually acidic, but a sheet volcano is formed from a basaltic lava, which is alkaline in nature. And if you look at this, you find out that a sheet volcano does not have secondary vent. Unlike composite cone volcano, you have a secondary vent here. Now, the height, it has a low height. It's not that tall like that of a composite cone volcano, and it also covers a large area and has a gentle slope. Now, here I have a summary of the difference between shield and composite cone volcano. So I said features in terms of height, shield is low, composite cone is higher. The base, shield volcano have a wide base, while composite have a narrow base. In terms of slope, shield volcano have a gentle, while strato or composite cone volcano have a steep slope. So you can actually pause the video and just look at the difference between the two. I think I've explained it earlier. Now, so let's look at features of an earthquake. Features of an earthquake. Now, your syllabus expects you to just know, to be able to identify the focus, the epicenter, the shock waves and seismic waves attached to the structure of an earthquake. So the focus of an earthquake, if you look at the diagram, usually sometimes diagram will be given to you to identify these positions on the diagrams, this part. So first, you find out that the focus is here, which is the point within the crust. So the focus is within the crust from which an earthquake begins. So the earthquake begins here within the crust, and the point directly above the focus from which the earthquake reaches the earth's surface is referred to as the epicenter. So the point on the surface directly above the focus, so you see it's directly above the focus, is where the earthquake is felt most strongly, is the epicenter. Then you have seismic or shock waves. These are ripples of movement. As you can see here, the red lines, they are ripples of movement passing through the earth crust, which come out from the focus. Now, there are what causes the shaking during an earthquake. So, but from this diagram, you can find out that there are two. Okay, don't worry, we'll come back to that. Let me not rush and waste so much time. Now, we are done with the first part of your syllabus. The second part for this same topic is for us to describe and explain the distribution of earthquake and volcanoes, plate boundaries. So the first thing we need to look at is plate boundaries. If we don't understand how plate boundaries work, we will not be able to describe the causes and also the distribution of this earthquake, because they are distributed along plate boundaries. So let's look at plate boundaries. So some of the keywords you need to look at for this second part is the plate boundary itself, which is where two or more plates meet, or a line separating two plates is a plate boundary. Please take note of this. I've seen it in a past paper before. Where two or more plates meet, or is a line separating two plates, is a plate boundary. Then tectonic activity is the movement of plate at plate boundaries. Then volcanoes is an opening in the earth crust through which magma from within the mantle is erupted onto the land. Then earthquake itself are vibrations within the earth crust, vibrations or shaking. Now, since we are looking at plate boundaries, which is where two or more plates meet, these plates meet, or a line separating two plates. Now, they're able to meet because there is what is referred to as movement that takes place along these plate boundaries. Now, if you want to look at what the mean is, the earth is divided into different layers. We have usually we have the core. We have the core. If this is the core, we have the mantle, and we also have, after the mantle, we have the crust. Sorry about this. After the mantle, we also have the crust. Now, the crust is divided into two parts. We have the continental crust and usually the oceanic crust. So, if we say the crust, which is the outer layer of the earth, is divided into two parts, oceanic crust, and we have the continental crust. Please take note of this. Now, the oceanic crust usually has a density of 2.7 gram, while the have a density of 3.0 gram, while the continental crust have a density of 2.7 gram. And what this means is the oceanic crust is heavier, while the continental crust is more lighter in terms of this two content. So if these two crusts meet, you find out that the oceanic crust that is heavier will usually be able to carry the continental crust that is lighter. So the oceanic crust usually sink under the continental crust. But what is the process that actually lead to the movement of these materials? Now, I try to use this here to depict how the crust earth structure work, because here this is the core and this is now the mantle and here is the crust. So what you look at here is I try to depict to make to simulate like more like the source of the heat here is the core, then the content inside the pot here, the content inside that part of the pot forms the mantle, and the cover forms the crust. So you agree with me that content inside while you are cooking, there is usually what is referred to as the convection current, which take place inside the mantle. Now the core heat make the mantle rise in a current. So the heat, like in this case now, the gas is providing the heat. So once it hits the magma, which is the content inside the mantle, in this case water, will begin to rise as the temperature increases. So the current, which creates more like a convection current. So the current cools as it gets closer to the surface. So as it moves from beneath, it gets closer to the surface, because the temperature at the surface is lower and the temperature here is higher. So as it comes to the surface, it cools, then it goes back down. It go back down, get heated, comes back up, cools, go back down, get heated, come back up. That's why you see when you heat something, the water keep boiling up, down, up, down, up, down, up, down, up, down. So the current cools as it gets closer to the surface. It travels under. So in that case, that is what is happening within the earth crust. So as heat from the mantle hits the content, it moves to the surface, get cools, come down, get heated again, move, come down. So what's that? That process is what, when the current cools down more, the convection current moves back down. So this continuous process. So there the temperature increases and the current rises again, and this repeats. So this continuous process of convection current is what lead to the movement of this plate. So how plates move is through that process. Now let's look at the types of plate boundary. The first type, the number one, is the destructive plate boundary. Now, what happened at the destructive plate boundary? You need to understand it, because sometimes if they want to ask you how earthquake or the causes of earthquake, they will either ask you at destructive or at constructive plate boundary. Now, in a destructive plate, you find out that the oceanic, it is usually between the oceanic and continental plate move towards each other. So the oceanic plate, let's say this is the oceanic, and this here forms the continental plate. Now they move towards each other. Now remember I told you earlier that the oceanic plate is heavier, so it's more denser. So the denser, you can, if you can't remember the word denser, remember heavier. That will give you a mark. So the heavier or the denser oceanic plate is subducted. So subducted means it moves under. It moves under or is beneath the continental plate. So what that means is, okay, this is the first diagram. So what will happen is once they meet, the oceanic plate will move under while the continental plate will remain on top of it. Now this will now lead to this point being called the subduction zone. Subduction zone. So as it is subducted, the plate causes friction. So that point where they meet, and this is forcing its way under, that's the oceanic plate is forcing its way to go beneath the continental, so they rub at each other. So here that they rub at each other, there will be what? Friction will be generated. So it's subducted, the plate causes friction by rubbing together, which results in an earthquake. So because of that friction, it leads to the buildup of pressure, and once the pressure is released, earthquake can be formed. Now the friction, so as it's moving under, the friction and the heat from the mantle, because it's going under the continental plate, it will now begin to meet the mantle that is under, which is also very hot. So the friction and the heat from the mantle will now melt the oceanic plate. That's why it's called destructive, because the oceanic plate gets destroyed in that process. So the hot liquid magma now rises to create a volcano with a violent eruption. So the type of volcano that is formed here is usually the composite volcano, like we looked at earlier. Now, but however, in a constructive plate boundary, what happened there is that the plate, here it can either be continental or continental oceanic or oceanic plate, whichever. But you find out that the plates move away from each other. So let's say they were like, it's a single plate before, and there are fraction lines, and the plate begins to move away from each other. So once they move away from each other, you find out that a space will now be created, and magma will now rise. So hot liquid rock or magma rises from beneath the mantle to fill up this space. So the magma cools and form a new oceanic plate. So it constructs a new oceanic plate. Usually this type of volcanic eruption is not violent, and the type of eruption you get here is usually the what is it called? Shield volcanoes. Okay, so next is the third type. Your syllabus need you to know is the conservative plate boundary. Now, in conservative, as you can see here, if you remember, this want to look like the structure of a volcano. If we bring here to be the focus, and we say here is the epicenter, and you have six seismic waves, then you have an earthquake. Sorry, structure of an earthquake. Now, however, so that should let you know that most earthquake, a violent earthquake, are around conservative plate boundary. This can also be called the transformed boundary, okay, as it is here. Another way you can call constructive plate can also be called the divergent plate boundary. And destructive plate can also be called the convergent plate boundary. Please just take note of that in case they use a different keyword. You should know what that means. Now, in transform plate boundary, as you can see here, using these arrows, you can tell that two plates try to slide past each other. So they are moving side by side each other. So they are trying to slide past each other. And what that lead is that friction. There will be high level of friction. So the plate gets stick and jammed together. And also you can have also high friction. Now, this will lead to a huge amount of pressure will be built, because both of them are still forcing to try to force past each other. So once the pressure is released, it usually causes a violent earthquake. Now the plates move on. These plates move on in millimeters. So you find out that there is no volcanic activity around transform or conservative plate boundaries, but there is a lot. It is the major cause of an earthquake. Now, distribution of volcanoes and earthquake. Now, in IG, one major thing I've observed over the years is once you are given a question, usually sometimes you get a question like this, and they'll ask you to identify which type of plate boundaries is there. What you should know is you should look at the direction of movement of the individual arrows. So in these arrows now, you find out that in this part, the two are moving away from each other. So if they are moving away from each other, that means this is the Antarctic plate and the Pacific plate. So Antarctic plate and Pacific plate are moving away from each other. And if you are moving away from each other, it's a constructive plate boundary. So we have constructive plate boundary here. This is also constructive between Antarctic and the Indian plate. This is constructive between Antarctic and the Nazca plate. Between the Nazca and the Caucasus plate is also constructive plate boundary. Now, but if you look at this plate here between the Eurasian and the African plate, both of them are moving towards each other. And so what you have there is a destructive plate boundary. This is constructive. Okay, this will be destructive. Looking for, I can't find anyone that they are moving side by side each other, but I'm just trying to let you know how it works. Okay, here is conservative plate. You can see it. So that's how it works. So you should be able to identify the type of plate boundary using the arrows. That's how this type of questions come out. Then next is looking at the distribution of volcanoes and earthquake. We are told that they are unevenly distributed. What this means is it is not spread equally around the Earth's surface. Earthquake and volcanoes are unevenly distributed. So there are places you have, and there are lots of places you don't have, and there are places you have high concentration of it, and there are places you do not have at all. Now, so it comes out as a 4-mark and sometimes a 3-mark question in IGCSE. So what you should know is what is here. First, you just write it is unevenly distributed. You've gotten 1 mark, and it's majorly found along plate boundaries. We've stated that it's formed around plate boundaries, is unevenly distributed. Another thing is it's encircled the whole of the Pacific Ocean. So the whole of the Pacific Ocean here, you have high concentration of earthquake and volcanoes, and that is the area that have that's why it's called the Pacific Ring of Fire. Now, it extends down the entire length of the mid-Atlantic ridge, and it also stretches across southern Europe, Asia, along plate boundaries. So that's just it. So now let's look at causes of volcanoes and earthquake. So volcanoes, let's start with volcanoes. I just had to bring this out, but we've explained it already. So causes of volcano, like I said, they can either ask you to describe how it's caused along a constructive plate or how it's caused along a destructive plate. So this should just be your answer. Now, at constructive margin, plates move away from each other. Remember, constructive can also be divergent. So when they say something diverge, that means they are going away from each other. So plates move away from each other, creating a space. So when the plates move away from each other, creating what? A space. So magma rises from the mantle to fill up the space or the gap. Magma now cool to form a new crust. That's it. Then in a destructive plate boundary between oceanic and continental plates, so oceanic and continental move towards each other. The oceanic plate is heavier, so it subduct. It will now go under. So subduct or move under the continental crust into the mantle. So the oceanic plate melts from friction and heat from the mantle. So newly formed magma is lighter. The newly formed magma is lighter, so it rises up, solidifies and cools to form a volcano. So those are the 2 ways. Then in the case of an earthquake, causes of an earthquake occur at conservative plates, which we've stated earlier. So plate boundaries where 2 plates slide past each other, the friction between the plates lead to build-up of pressure. So once the pressure being released as plates move suddenly, pressure being released, this will send shock waves through the crust from the focus, leading to an earthquake. Okay, now lastly, the last part is for us to describe and explain hazards, opportunities, and possibly management or solutions to provide some solutions to earthquake and volcanoes, how to manage it, because it happens. Now let's start with hazards associated with volcanoes. Now usually it depends. You shouldn't to put pressure on yourself in terms of this, because in some questions they will ask you what is the impact of volcanic bomb, pyroclastic flows, because those lahars and ash cloud, eruption clouds, what are their impacts. So they might mention these keywords like what is the impact of pyroclastic flow, what is the impact of volcanic cloud, what is the impact of ash cloud, what is the impact of volcanic bomb that we looked at earlier. Now, what is the impact of the lahars as they erupt from a volcanic eruption? Now, all of them have impact, separate impact, and in some question they will just ask you to describe the impact of volcano or the hazard associated with a volcanic eruption. So you can just write, because all of them here can lead to death though, so you can just move around that angle. Now, so see, hazard type associated with volcano, we have ash cloud. So what it is, when you have ash from a volcano, can stay in the atmosphere. When it finally settles, it covers large land and town with what? The ash. Now, what is the impact of this ash cloud on people and the environment? So it can block the sun, that's environment now, causing cooler weather and affecting crops. And people, it can affect flight. So you won't, flight will have to be cancelled. Then pyroclastic flows, which are very hot cloud of rocks, ash, and volcanic bombs. And what is the impact? It kills people, it kills animal, that's environmental impact. It damages the environment like vegetation. It destroys infrastructure, roads, hospitals, buildings. Now, what we have mud flows called lahars. So lahars are ash settled that and mixed with water. So when it's settled and mixed with water, it's called a mud flow or a lahars. And the impacts include it causes water pollution, it destroys vegetation, it also destroys farmland. So you see, now lava flow itself, which is the hot magma that reaches the earth's surface. So when it flows, so slow moving from a shield volcano is actually slow from shield volcano because it's from constructive plate boundary. So only destroy infrastructure but rarely kill people because it's slow. So it destroys infrastructure and vegetation. Then volcanic eruption releases sulfur and nitrogen oxides, and you know that sulfur oxide, when released into the atmosphere, can actually mix with the cloud to form an acid rain. An acid rain damage building, it affects plants and animal, and it also acidifies the soil and making it unsuitable for the growth of certain type of plant. Okay, so let's look at factors that influence the extent of damage by an earthquake. So earthquake also cause a lot of damage, even volcanoes. So you can put earthquake and volcanoes here. Sorry, that's not too clear, but so like I said, there are certain factors that affect the extent of damage caused by earthquake, and one of those is population density. If the higher the population density, the higher the damage. Another one is the magnitude or the strength of the earthquake. So you find out that the stronger the earthquake, the more damage it causes. Now, I didn't include this in this material, but remember that the magnitude of an earthquake is measured using a Richter scale. Then the extent of damage, I think that is measured using the Mercalli scale, thereabout. So distance from the epicenter. So those that are closer to the epicenter tend to have more damage than those that are far away. Then the types of building. More economically developed countries have what is referred to as seismic buildings, which are earthquake proof, which help to reduce the impact of an earthquake. Unlike most LEDCs, they don't have the money to provide that. Then time of the day, earthquake during busy time causes more damage. Then the education level of people within that locality. So the higher the education, the more they know how to deal with an earthquake, the ability for them to predict, to study, to know when it's about to erupt and take precautionary measures. Then we also have the types of rocks in that area. So area with softer rocks, we have more damage, but areas with harder rocks, we have less damage from an earthquake. Now, let's see what is the impact of earthquake on people and the environment. So the impact is quite similar to that of volcanoes. So it causes death of people, animals. Earthquake can lead to fire outbreak if it bursts through gas pipes. Water pipe can burst, making water contaminated, leading to waterborne diseases. Crops, humans and animal crops will be spread across that landscape, and you have accessibility becomes very difficult because it will be difficult for you to drive within that area because the crust have been distorted. Then vegetation is destroyed, buildings damaged and destroyed. Tsunami can actually follow an eruption. So, and all this for you to come back to your normal state, it will have you spend more. So reconstruction costs, all these are major impact of earthquake. So, however, despite we look at impact, there are certain importance you can get from an earthquake. So, what are the importance of earthquake? One is that it is earthquake makes the soil fertile, so it comes with a lot of minerals and nutrient because it's rocks. And you know the definition of a rock is that rocks are aggregates. They are aggregates of minerals. So rocks are combinations of minerals. So if you know that, you agree with me that volcanoes provide minerals, and these minerals make the soil fertile, therefore suitable for agriculture, which can eventually lead to higher yield. Um, uh, this earthquake also provides source for geothermal energy, which is energy you get from the earth crust. So this help to provide cheap source of electricity. It also attracts tourists, so need for tour guides and therefore providing jobs. So you see, we are just looking at multiplier effect of this. So attract tourists, you need tour guides because it provide job. This is important. We have like two here: geothermal energy, which provide electricity, fertile soil, so good for agriculture. So it's a source of minerals. So examples are sulfur, quartz, like I said, rocks are aggregate of minerals, and volcano is the major if you look at rock cycle where most rocks start from, which is used for glass making, therefore providing jobs for the miners. Education, like volcanologists, which are people that study volcanoes, and they need that to go to do their own study. Now, however, it has been established that despite these hazards, people still live in hazard prone regions. So people still live in regions with earthquake and volcano. So why will people live in regions that have constant earthquake and volcano and they don't live? And there are reasons for it. One of the reasons is there is this sentimental attachment. They have lived there all their lives, so they don't have anywhere to go, they don't want to go anywhere. Usually they are close to family and friends, and work in the area, like they are tourist guide, so they don't tend to live. That's where they have job. The education is in the area. They cannot afford to move, more like there is no money, so they can't move. There are also some are willing to take the risk to remain there. Seven is that there is confidence in prediction and safety. So they believe in the authority to predict and provide safety for them. So they trust the system. So they are also prepared to take the risk. So as a result, they tend not to move, and you still have people living within that region. Now, there is this usually popular question that comes out in IG where they ask you why hazards are more deadly. Why is it more deadly in LEDCs than MEDCs? Now you see, one of the reasons is uh, obviously people die more in LEDCs from natural disasters than MEDCs, and these are some of the reasons. One is poor quality building infrastructure, road, bridges, which easily collapse as building regulations are not enforced in LEDCs. Now, high population density also in LEDCs, so more depth, obviously. Remember when we look at reasons why, so all this plays a long role there. So high population density, poor medical facilities or services, poor medical services, hospitals, and get destroyed in the process. Therefore, people cannot be properly treated for their injuries. Now, there is also lack of planning, lack of emergency procedures, lack of emergency shelters, lack of preparation before the eruption. There is poor education. Example is earthquake precautions. Is most of them don't know about it. There is also lack of money. Very important, lack of money for rebuilding, assistance and rescue process. So you see, all these help make earthquake to be more deadly in LEDCs than in MEDC. So take note of all this, please. Then lastly, for this topic is how do we manage volcanoes and earthquake? Now, in managing volcano, you need monitoring. You need to monitor it, so warnings and predictions. You need to have evacuation plans. You relocate homes. You need to have emergency action plans. And another thing, you can redirect lava flow. So if the lava is moving, especially in constructive plates, because it's gentle, it's not violent eruption, you can actually rechannel the lava flow, so you divert it from where people are actually residing. Then spraying water on volcano as it's erupting, so it will make it to solidify and cool faster. Another way of management is education of the people. You should practice volcanic drills just like you have fire drills. You should also practice volcanic drills so you know what to do in case of an eruption. Building reinforcement can also help in that process. So that's how you manage volcanoes. Now, in the exam, let's say if they ask you how do you manage earthquake, you see this all the content here for managing volcano. Outside writing instead of writing volcanic drills here, you can write practice earthquake drills. Education is similar to what you do to manage an earthquake. So you just need to know at least 5 of them. If you want to know 5 that are similar in both, you are good. Now, here you see managing earthquake, you practice earthquake drill. Earthquake, you should have earthquake proof buildings. You should have evacuation plans, shatter roof glass to prevent breaking of glasses. You should also have monitoring, warning and prediction, automatic gas switch off to prevent fire outbreak from an earthquake, build on hard rock instead of soft rock, and have a very deep foundation. Then there should be emergency services, just like in earthquake, and add metal framework to your building to help them withstand the vibration from the seismic wave. Okay, with this, I'm done with the Igcse syllabus on earthquake and volcanoes. What is left is the case study, which I have a video on that you can watch to catch up. Then lastly, I'm going to do a classified past paper, classified past questions on this topic. So once you watch the video, you can look at past questions, which will now help you to know how you should answer questions on earthquake and volcano. So thank you.